Hello students, how are you? So hope you all are doing good. Right. So good afternoon guys. I hope you all can see me. You can hear me. Please let me know through the chat box. Can you hear me? If you can hear me, please let me know through the chat box. Okay. Yeah. So now let's start our discussion with today's class. In the yesterday only you people have exam over enable test. So as per the guidelines, I would like to discuss the paper here. So now I request everyone to please take pen and paper and try to write at least what are the things are happening here. Okay. So now in the first question you can see how many moles of magnesium phosphate, that is Mg3PO4 twice, will contain 0.25 moles of oxygen atoms. Pretty simple question, very easy one. So the question is how many moles of magnesium phosphate will contain 0.25 moles of oxygen atoms. Okay. So now in the given question we can say that from the given question, okay, we can say from the given question is Mg3PO4 twice. Generally, if you are seeing this one, how many oxygen atoms are there? So for 1 mole of Mg3PO4 twice, for 1 mole of Mg3PO4 twice, if you see here, how many oxygens are there? 2 into 4. So that is 8. 8 oxygen atoms are there. 8 oxygen atoms are there. So for 1 mole of Mg3PO4 twice, magnesium phosphate PO4 twice, containing 8 oxygen atoms. Okay, now they are saying 8 moles of oxygen atoms, 8 moles of oxygen atoms. Now 0.25 moles of oxygen atoms, 0.25 moles of oxygen atoms. They are asking how many moles of Mg3PO twice will be present. Okay, just you know the unitary method, you have to do it. That is, we can calculate 1 into 0.25 divided by 8 is equal to x, then x will become 3.125 into 10 to the power of, okay, 10 to the power of minus 2, 10 to the power of minus 2. Okay, so very simple question, okay, very basic question from mole concept. Again, remember 1 mole is always consists of Avogadro number of atoms, molecules or particles, and 1 mole is simply nothing but mole can be calculated by weight by gram molecular weight, okay, or number of entities divided by Avogadro number, or volume 22.4 liters at STP, standard temperature pressure. This is for gas. So in case if they will ask how many moles of gas can occupy at STP, that is 22.4 liters. So 1 mole of a gas, 1 mole of a gas occupy 22.4 liters. 1 mole of a gas will occupy 22.4 liters. I hope you all are clear with this. Right. Second is also from mole concept. So 2A plus 3B gives rise to C. Initially have 2 moles of a reactant A and 3 moles of a reactant B. Then which of the following statements is true? Okay. So they are talking about the limiting reagent question here. So let me check with you. Okay. So yeah. So they are saying 2 moles of A plus 3 moles of B is producing C here. Now, based upon that, given what they have given, again 2 moles of A and 3 moles of B is going to give the products. They are going to say that going to give the products. Now, in the question, what they are asking, find the which is a limiting reagent and what is going to be consumed first. That is the question. which is what A is a limiting reagent and will get consumed first. B is a limiting reagent and will get consumed first. Both A and B will get consumed at the same time. Okay, so now here we can say that we know that stoichiometric coefficient we have to see. For 2 moles of A, 3 moles of B is required. You are going to get 1 moles of C. Now, in the question is also given 2 moles of A, 3 moles of B. So there is no product, there is no reactant will be consuming first. Both A and B are in the simple ratio of the stoichiometric coefficients. So they are in the simple ratio of the stoichiometric coefficients. So that is why these are stoichiometric equations. So stoichiometric equation will not call as any limiting reagent because given moles are same as the stoichiometric coefficient. Let's suppose if I'm giving you 1 mole of A. So they will say you that 1 mole of A is reacting with 2 mole of B. Okay, so find the limiting reagent. If they are asking the question, find the limiting reagent given 1 mole of A and 2 mole of B. How do you find that one? Very simple. From the basic concept, you can see that 2 moles of A is required 3 moles of B. This is the basic requirement. Basic requirement. Okay, na? So for the basic requirement, 2 moles of A is going to require how much? 3 moles of B. Clear? Okay. So we can say that for 1 mole, how much it should be required? 3 by 2 moles of B. So that is for every 1 mole of A, for every 1 mole of A, it required 1.5 moles of B to get 1 mole of to get the product, that is the case. So for every minimum requirement is how much? For 1.5 moles you required 1 mole, but here how much it is there? Given is 1 mole, but here we are having 0.5 as excess. Okay, 0.5 is excess here, so that is why we can say that A will be limiting reagent in this case. Okay, A will be the limiting reagent in this case. Okay, other models is also there. Just given moles divided by the stoichiometric coefficient. Given moles divided by the stoichiometric coefficient. If you write them, then you can easily get the limiting reagent. Okay, so that is 1 by 2, that is 3 by 2. So 1 by 2 you are going to get 0.5 and this will get 0.6. So sorry, 1.6. 1.5 you are going to get. Sorry, this is 2 by 3. 2 by 3 means 0.6. So 0.5 and 0.6, 0.5 is lesser. So that is why A will be the limiting reagent. A will be what? Limiting reagent. I hope you guys understand this one. Okay, now next one. According to the Bohr's theory, the angular momentum of an electron, okay, in the third orbit is the big, very easy question in the complete question paper. According to the Bohr's theory, I will erase everything. Just a minute. So sorry. Yeah. So now you can see. So now, so according to the Bohr's orbital angular momentum, the electron in the third orbital. So a very, very important angular momentum is equal to mvr is equal to nh by 2 pi. And remember, h by 2 pi is called as h cross. They can also write as h cross. So third orbit mean L will become 3, N will become 3. That is mvr is equal to 3 h cross. That is the answer. Okay, mvr is equal to 3 h cross. Okay, is it clear to you now? Okay, mvr is equal to 3 h cross. Okay, I hope you all guys like this. Next, an unknown surface is irradiated with the photons and unknown particles are emitted from the surface that it follows the, we'll do one thing. First of all, we'll solve all the easy questions. Okay, when we solve all the easy questions, then we can, solve the difficult one when we have a time. So now listen here. Okay, next question is what? Yeah, so now this is the 31st question. Okay, now 30th question, if you can see, right? So what is the 30th question saying, guys? Which of the following has the highest electron affinity? Very easy question throughout the question paper. Highest electron affinity will be chlorine, then fluorine, bromine, and iodine. This is in the case of halogen family, that is group 17 family. Okay, but if you see for the 16th family, first sulfur, then silurium, tellurium, polonium, okay, and then you will get oxygen. Okay, so very most important, guys. Why there is an exception between chlorine and fluorine? Because of small size of fluorine, okay, or we can also call it as large size of chlorine, okay, small size of chlorine and large size of chlorine. Okay, so due to the small size, there will be a greater repulsion. So let's suppose this is fluorine. So what is electron affinity? The energy required to, okay, the energy release when we add an electron. So these are the fluorine electrons. So these are the fluorine electrons. So if you see, the fluorine will have 7 electrons in its valence shell. So 3, 4, yeah, 7 electrons. Now you are trying to add additional electron to here. Now you are trying to add additional electron here. What will going to happen when you are trying to add? There will be a strong repulsions will be takes place. There will be a strong repulsions. Okay, so this is a fluorine atom. Okay, there are 7 electrons here, and you are trying to add another electron here. So there will be electron repulsions. What will going to happen? Electron repulsions will going to takes place. So these electron repulsions, what they will do? These electron repulsions will, like, try to push the electron, and because of small size and the electron repulsion size is small, and the electron repulsion, there is less energy will be released. But whereas chlorine is having larger in size, so addition of electron will increase the energy, means there is a release in energy will be more. So now first chlorine, then fluorine, bromine, then iodine. But remember, guys, krypton and argon will have similar electron affinities. Okay, in case in 1A family also, potassium, rubidium, and cesium are having nearly same electron affinity. In JEE Mains 2022, they asked which of the following will have nearly same electron affinity. So these are the conditions, very most important, you have to remember. Okay, and what about electronegativity? Electronegativity, first fluorine, then oxygen, then nitrogen. This is very most important. Okay, so this is about electron negativity. Okay, now second one, the state of hybridization of the central atom and the number of lone pairs over the center in the POCl3. Very simple, POCl3 ka hybridization they are asking. So they are asking about what? They are asking about POCl3. They are asking about the hybridization of phosphorus. And we know phosphorus valence electrons are how many? 5. So the valence electrons of phosphorus is 5. 1, 2, 3, 4, 5. And one thing you can clearly say from here is, you just make, always remember, whenever there is oxygen is there, you have to make a double bond with the oxygen. So how many chlorines are there? 3 chlorines. 1, 2, and 3. So now we can clearly say that half into, how to find the hybridization? First you need to find the hybridization number. Half into valency of the central atom plus number of single bonded atoms, okay, minus positive charge plus negative charge. Okay, so this is very most important, right? So now we can clearly say that half into, what is the valence electrons of phosphorus? 5. How many single bonds are there? We should not count this. Why? This is double bond should never count. So now how many single bonds? 1, 2, 3. So that is 3. 5 plus 3, 8. 8 by 2, 4. Remember, if the hybridization number is 2, then we will call it as sp, then the geometry will be linear. If it is 3, then it will become sp2, then it is trigonal planar. Okay, and if it is 4, it will become sp3, that is 1 s orbital and 1 p orbital, 1 s orbital, 2 p orbitals, like that. So this will become tetrahedral. octahedral. Okay, and if it is 5, then this will become sp3d, that is trigonal bipyramidal. Trigonal bipyramidal. Okay, and next 6 means sp3d2, that is octahedral. That is octahedral. I hope you all guys clear with this. Okay, so sp3, that is tetrahedral, and they are asking about number of lone pairs present here. There is no lone pair, all are bonded pairs only. So 4 bonded pairs plus 0 lone pair. Okay, 4 bond pairs and 0 lone pair. Here double bond is also considered as a single bond when you are calculating the bond pairs. But when you are writing the hybridization, you don't consider. But when you are considering how many bond pairs are there, you consider this double bond also one single bond pair. So total 4 bond pairs plus 0 lone pair. Okay, I hope you guys are clear with this concept, right? Next one, same concept related question hai. Again, next one is also same related concept question, right? The correct increasing bond angle among BF3, PF3, CLF3. Okay, so they are asking about the bond angle. They are asking about what? Bond angle. So how do you write the bond angle, guys? Right? They are asking for BF3, PF3, and CLF3. Okay, so they are asking about the bond angles. Now, first of all, we all need to find the bond order. Remember, for SP, the bond angle is 180 degrees. For SP2, the bond angle is 120 degrees. For SP3, the bond angle will become 109 degrees, 28 minutes. For SP3D, that will become 90 degrees and 120 degrees. How, sir? Just see. So if I am talking about PCl5, let's suppose here central atom is there. Here is the central atom. Okay, and on the top this is 90 degrees and the bottom 90 degrees, and this is the bond angle is 120 degrees. Okay, and next one will be sp3d2. So that is what, how much? 90 degrees. Octahedral, all the bond angle will be 90 degrees. Now first for BF3 we need to find the hybridization, that is half into what is the valency of boron? Boron is 3. How many single bonds? 3. So the hybridization number will become 3 and this will become sp2. The bond angle will become 120. Next for PF3, half into phosphorus valence electron, just before we found 5 plus 3, 8. Then this will become sp3. The bond angle will become what? 109 degrees, 28 minutes. But wrong. Why? Because if you see for PF3, phosphorus, you have to write. Okay, sorry, this is only we are having 5 electrons, right? Phosphorus is having 5 electrons, 1, 2, 3, 4, 5, right? So now PF3 we have to write F, F, F. So there is one lone pair and lone pair bond pair repulsions will be there. So that is why it is not 109 degrees 28 minutes. It will be less than that. It will be less than 109 degrees 28 minutes. Okay, then what about CLF3? CLF3, if you can see for the CLF3 case will be half into what is the valence electrons of chlorine, that is 7 plus 3, 10, that is sp3d. So sp3d means I just told you, here you are having a bond like chlorine will be at the center, one fluorine will be at the top, another fluorine will be at the bottom, and another fluorine will be at the this axial plane. This is called as equatorial plane, and this is called axial line. So now you may have a doubt that, sir, why you are keeping one fluorine on the top, one fluorine on the bottom, and one fluorine on the equatorial plane? Very simple. If you see here, chlorine is there. Let's suppose if I am trying to keep 3 fluorines here. Okay, if I am trying to keep 3 fluorines here, what is going to happen? Because due to the, if you am keeping lone pair here, if I am keeping the lone pair here, obviously lone pair will be present here. Okay, because total number of valence electrons is 7. So that's why 1, 2, 3, 4, 5, 6. So here lone pairs will be present. 3 bond pairs and 2 lone pairs. 3 bond pairs plus 2 lone pairs. So here the shape is called as bent T shape. The shape is called as bent T. Okay. Let's suppose if I'm trying to keep the fluorines in the equatorial plane, there will be a strong repulsions. The structure will be highly unstable. So that's why what we have done, the fluorine most electronegative atoms, they have kept in a axial line in such a way that they will have a maximum bond length because of fluorine repulsions, and minimum repulsions will be take place. So that is why whenever we are keeping, okay, whenever we are keeping anything, we all just need to remember one thing, that lone pair in the equatorial plane, lone pair on the equatorial plane will be having minimum repulsions, will have more stability. Okay, minimum repulsions and maximum stability. I hope you guys are understanding this one. Right. Next one is Avogadro's law के ऊपर dependent है. Right. So next one is Avogadro's law के ऊपर dependent है. So 33 question. So identify. So next one, 3 identical containers A, B, C of equal volume containing oxygen, neon. So based upon that, what will be the answer, guys? Which will have more bond angle? Tell me. For 32 question, which is having more bond angle? BF3 will have more bond angle than PF3 than CLF3. Yes. So BF3 120 degrees, obviously highest. Among these all are having wrong answer. So only one case is D. 32 will be become D. Right. Next one, 3 identical containers A, B, C of equal volume containing oxygen, neon, and methane, respectively at the same temperature and pressure. The decreasing order of their masses is, the decreasing order of their masses will become what? The decreasing order of the masses. Simple thing, mass means you just need to consider the molar mass also. The reason, because volume is directly proportional to n, number of moles, and moles is directly proportional to the mass and inversely proportional to the gram molecular mass. So जिनका gram molecular mass ज़्यादा है, so sorry in for Hindi. So for the higher the molecular mass, and we can also say that lower the gram molecular mass, lower will be the weight. Okay, so from this one we know oxygen is having how much weight? 32. Neon is having how much? 20, because neon will exist as a monoatomic gas. Methane CH4 is having 16 grams. Okay, so based upon that one, okay, oxygen will have more mass compared to neon than CH4. Just simple, whatever the order they have given, that is the answer. Why? Because we have to find in the increasing order of molecular mass. So oxygen gas will have more molecular mass. So that is why the decreasing order of masses will become this one. Okay, I hope you guys are clear. Next one is very important question. Next one. Okay, JEE mains, for JEE mains, this is really important. Focus this question, guys. Yeah. So next question, if you see for the 34th question. 34th question is, we take a gas and plot PV versus P, and we will get a curve which is a straight line with a positive and finite slope. Okay, they only mentioning everything. So they have plot a graph with PV versus P, and they got a curve which is a straight line and with have a positive and finite slope. Which of the following is true for this gas? They are asking which of the following is true for the gas. Okay. I'm so sorry, guys. There is, yeah. So now, okay. So very important. They are drawing a graph PV versus P. Let's suppose PV versus P. So based upon to drawing the graph, they have observed a positive slope. So positive slope means which is like look like this one, which is similar to y is equal to mx plus c kind of graph. Okay. So to plot these graphs, these are the 3 conditions they have given. These are the 3 conditions they have given. What we have to neglect here? What we have to neglect here? So that for that one, we need to first see the Van der Waals gas equation. So what is Van der Waals gas equation? Van der Waals gas equation is P plus A into N square by V into V minus NV is equal to what? C, or any particular constant. Let's suppose any RT actually, RT, PV is equal to nRT case mein, this one C we can written as constant. Now, if we neglect a term, we have to neglect A or B. so that it should comes in the form of y is equal to mx plus c. Like this it should come. Let's suppose if I am ignoring A, if I am taking A as negligible, what is A indicates here? Intermolecular forces. B indicates dimension factor or size factor or volume we can say, but A indicates the intermolecular force. Okay. Now let's suppose if I'm ignoring this term, now it will become P into P minus NB is equal to C. That is PV minus PNB is equal to C. Then PV is equal to PNB plus C. So here we can say that if PB, if you consider it as y-axis and P as x-axis, and NB is a slope, which is M and C, so that is y is equal to mx plus C. Pretty clear that if I am trying to plot a graph between PV versus P, you are going to get a straight line and having a slope of what? Theta. Okay, having a slope M here. Okay, I hope you guys understand this one. Okay, so PV is equal to PNB plus C. Okay, so that's why we can clearly say from this question is if we are neglecting the A, okay, then the graph will be a straight line. So the answer will become what? Option A. So that is first one, that is option C is the correct answer. Okay, next one. The species by definition having a zero standard molar enthalpy. Okay, the species by which having a zero standard molar enthalpy of the formation at 298 Kelvin. Very important thing is this point. 298 Kelvin means what? 25 degrees Celsius. So at 25 degrees Celsius, we know that bromine, chlorine, mercury will exist as a liquids. Means they will have some standard molar enthalpy at that temperature. But the only gas, not chlorine, sorry, gas, mercury and H2. What? Water gas, guys. So bromine, H2O, and mercury. Hg is mercury, right? Hg, mercury are always exist in the liquid at 25 degrees Celsius. The only gas which can exist, the only element or the only molecule which can exist as gas is chlorine. Chlorine can exist in the form of gas. So that is D. Okay, Cl2 gas. I hope you guys understand this one. Okay. Next, we are going to see just a minute. I'm just zoom it out. Okay. So next 36, 37, 38. These questions are based upon the thermodynamics concept. So thermodynamics concept and chemical equilibrium constant. So these questions you people require more knowledge, but still we can try this question. So 4 moles of 4NaO2, they have given the standard enthalpy formation of this equation. And if N2O5 solid is formed instead of N2O5 gas in the above equation, what will be the delta RH value? Okay, so the delta H sublimation will become what? The delta H sublimation of N2O5 is given as 54 kilojoule per mole. Okay, so the delta H of sublimation energy is given as 54 kilojoule per mole. Okay, so yeah, in the above equation, these kind of things are found. So what we have to do? So first, so let's suppose here that is solid formation is taking place. Question direct is in the instead of this, if it is a solid, what will going to happen? So nothing will going to happen, guys. Just let's suppose first we are writing 2NO2 plus O2 gives rise to 2 and I'm seeing the question from my mobile, guys. 2N2O5. Okay, so remember, guys, NO2 is also called as brown gas. NO2 is also called as brown gas, and another one is N2O3, that is blue solid gas. Blue solid gas. So these are the 2 nitric oxides where they are having the color. Okay. So now in the second, what they are saying, instead of N2O5 solid, sorry, gas, we need to convert them into what? Solid. So that is 2N2O5 solid. So we know that the delta H of this one is already given, that is minus 111 kilojoules. But the conversion for 1 mole they have given. For 1 mole, it is minus 54, but we are having 2 here. Just multiply with 2. Then this will become what? Minus 108 kilojoules. Just add both of them. Then delta H final will become what? 1 minus 11.11 kilojoules plus minus of 108 kilojoules. So then you are going to get minus 219 kilojoules. Okay. So just observe the question and try to write the equation, balance the stoichiometric coefficient, multiply with the stoichiometric coefficient, then you are going to get delta H1, delta H2. If you see, if you want to find the final one, then what will going to happen? This gas and this gas, this is also gas and this is also gas, both will get cancelled. So that is why I have written 2 here, because in the question 2 moles. So we need to provide 2 moles of solid. So this is for what? Sublimation energy, right? But for sublimation energy given in the question is for 1 mole. But we want 2 moles, so that's why I multiply with 2. Okay, just clear everybody. Okay, I hope everyone is clear with this. Right. Next question is chemical equilibrium question. So this is a quite big question. I can say that it takes some bit time. So we'll discuss this one later. Okay. Next, if you can see this question. 40 ml of 0.1 molar. 0.1 molar. Okay. Ammonia is mixed with 20 ml of 0.1 molar HCl. What will be the pH of the resulting? Okay, so the pKb is given here. pKb is 4.74. Okay, and 40 ml of 0.1 ammonia is mixed with 20 ml of 0.1 molar of HCl. So here ammonia is mixing with what? HCl. So this is a strong acid and this is a base. Okay, so we can clearly say from this one. Okay, from this one, pH calculation they are asking. So the pH calculation will be done by pH is equal to, okay, because it is a basic solution, first we have to calculate for the pOH. pOH will be like what? pKb plus log into whatever the salt going to formation, NH4Cl. If you are trying to get, you are going to get a salt here, NH4Cl, divided by the concentration of NH3, divided by the concentration of NH4OH. Okay. Okay, or NH3 or NH4OH. So based upon that, you can calculate. You are going to get the answer from here. Okay. So next, strong acid, strong base, weak acid, weak base का concept लगा के करना है. आप सभी लोग थोड़ा ध्यान दीजिए इसके ऊपर. And question number 39. These all are the inorganic question. Let me finish them fast, very fast. Okay, so just see here, MnO4 minus is a good oxidizing agent in different mediums, changing from MnO4 minus to Mn4 plus 2. Okay, so very simple. These are the conversations here. So they are asking about the oxidation number. Very simple. You can easily calculate the oxidation number. Let's suppose for MnO4 minus, if you are calculating, if you take this as X, and for oxygen, we know that is minus 2. So how many oxygens are there? 4 is equal to minus 1. Okay. So then this will become what? X minus 8 is equal to minus 1. Then X equal to plus minus 8. Na? So minus 8 is equal to minus 1. So plus 7 it should come. But though the change in oxidation numbers they are asking. Na? So the change in oxidation number, this is plus 7 and next one is plus 2. So here we can say this is plus 7 and this is plus 2. So the change in oxidation state is plus 5. Okay, then from plus 5 to this one, and this will become what? And here this is MnO4 2 minus, that is minus 8 is equal to minus 2, X is equal to minus 8 equal to minus 2, then X equal to plus 6. Plus 6 means what? How much difference? Plus 4. Plus 5 plus 4 is there, and then next one this is plus 4. Plus 4 means 0. Okay, so next one is X minus 4. Okay, X minus 4 is equal to 0, then X equal to plus 4. So the change in oxidation state is 0 here. Okay, MnO4 to MnO2. Sorry, this is plus 6 now. So plus 6 say plus 4, plus 6 plus 4 plus 2. So the only option is 39C. Okay, the final one is 5421. 5421. Okay, so like that you have to change. So the mass percentage of deuterium in heavy water is, the mass percentage of deuterium in heavy water is, very easy question. A very easy question actually. Mass percentage they are asking. Again, this is another question from, okay, mole concept. Mass percentage they are asking. We know that molar mass of deuterium is how much? Molar mass is 2 gram per mole. Okay. For tritium, 3 gram per mole. For hydrogen, 1 gram per mole. So now for the molar mass of heavy water, okay, molar mass, this is for deuterium molar mass. Molar mass for D2O. How much? D plus 2 times of oxygen. That is 2 plus 2 into 16. So that is 2, 16 are 32. 32 plus 234. Okay, D2O, right? Sorry, I written DO2. Right, wrong. D2O, that is 2D plus O. That is 2 into 2 plus 16. That is 16 plus 4, 20 gram per mole. Very simple. They are asking mass percentage of D. That is 2 by 20 into 100. So that will become 10. So then total, the answer will be, okay. Oh, they are, acha. 2 is for one deuterium, but we are having total number of atoms will become 2. Remember, guys, how to find the mass percentage? Mass percentage can be calculated by number of atoms into mass of each atom. Mass of each atom. Mass of what? Each atom divided by the molar mass. Divided by the molar mass into 100. Divided by the molar mass into 100. Then that is will become what? 2. Number of atoms is 2. What is the molar mass? Atomic mass of deuterium is 2 divided by what is the molar mass is 20. So then this will become what? 20%. Then this will become what? 20%. Very easy question, guys. Very easy question, right? So the answer will become 20%. When ionic hydrates react with water, the products are very simple. Ionic hydrates are what? What are ionic hydrates? Tell me. Best example like sodium hydroxide, yeah, metallic hydroxide, like sodium hydroxide. If you take, this is an ionic hydrate. Calcium hydroxide. If they are reacting with H2O, what they are going to form? They are reacting with H2O. What they are going to form? Right, they are going to form a basis, right? From here, what you are going to get? NaOH. From here, CaOH twice. So they are going to form a basic compound. So they are going to form a gas and along with the basic solution. So they are going to form a gas. What type of gas they are going to produce? Here we are reacting with water, H2 gas. So if you want me to write the equation, I'll write that one. I'll write here. A minute. I'm writing the equation here. NaH plus H2O gives rise to NaOH plus H2. Okay, let's suppose CaH twice. Why CaH twice we are taking? Because calcium will present in +2 state. If you are reacting with H2O, what is going to happen? Calcium hydroxide twice plus H2. Gas will be going to produce. Okay, these are the some of the important reactions for the particular concept. Okay, guys, I hope you guys understand this one. Okay, and this is very most important, guys. 40-second question. Take a screenshot or write down. A chemical compound A is removed for the temporary hardness from water. It reacts with sodium carbonate to generate a caustic soda. When CO2 is passed through it, it turns into cloudy. What is A here? I will write the overall equation here. No need to worry. So the overall equation is calcium hydroxide is the answer actually. Calcium hydroxide upon treating with, okay, HCO3 twice gives rise to 2CaCO3 plus H2. Okay now, then again if I am reacting with Na2CO3, sodium carbonate, you are going to get a caustic soda. What is caustic soda here? CaCO3 plus 2NaOH. Okay, these are the reactions. Temporary hardness can be removed by calcium hydroxide. So that is why the answer will become what? Calcium hydroxide. 42, the answer is C. Very, very most important for your examination point of view. Okay. So next question, if you see. Yes. So the next question, a metal M is readily forms water with a soluble MSO4. Okay. So then water, okay, soluble in metal SO4, but not in hydroxide. And an oxide MO which becomes inert on heating, the hydroxide is soluble in NaOH, the M is. Ideally, these kind of questions are inorganic questions. Okay, so for this one, we know that some of the important points we need to keep in our mind whenever we are doing. Okay, so how to find these questions is like, okay, right. So we need to see which are soluble and which are insoluble. Okay, so if you know what type of the elements are soluble, what type of the elements are insoluble, we need to remember that one. Beryllium and magnesium are water soluble reactant, but they are insoluble in hydroxide. We haven't seen beryllium hydroxide. Okay, this is not going to form. And another important thing, lithium and magnesium, beryllium and what is aluminum will have a diagonal relationship. On that basis also we can say that, so the hydroxide is soluble in NaOH metal is beryllium, because magnesium is what we are going to say that highly soluble, but whereas beryllium is amphoteric in nature. So when it is amphoteric in nature, so it can be soluble in NaOH also. Okay, so graphite is a soft solid lubricant, extremely difficult to melt. The reason for the anomalous behavior is, what will be the reason? It is a non-crystalline substance. Okay, has a molecules of variable molecular masses like polymers. Okay, is an allotropic form of diamond. No. Has a carbon atoms arranged in large plates, strong carbon bonds with weak interplate bonds. So question number 44, highly technical. It is non-crystalline solid, but having a hexagonal, like arrangement. So it is a network solid. Diamond is a network solid. But if you see the diamond is somewhere around like this. Okay, hexagonal rings will be there. Okay, so the hexagonal rings will be present like this. Okay, so these are the hexagonal rings. So these hexagonal rings are formed as a layers. Okay, formed as layers. So the bond between them are very weak. Okay, so has a carbon atoms arranged in large plates. Yes, these all are the large plates, and strong bonds with the weak interplate bonds. Means the bond between one layer to another layer will be very weak. The bond between one layer to another layer will be very weak. Very weak bond. Okay, so when the bond between the layers is very weak, so this is the correct answer. Okay, so all others are not perfectly assigning, so this is the correct answer. Next one, very, very most important, guys. Boron का reactions है, boron boron का reactions है. Just a minute, don't know why I can. So what is the reactions for this one? B2H6 upon react with H2O, what you are going to get? Boric acid, H3BO3. Okay, now so this is called as boric acid, or we can also write as, okay, BOH thrice, like that also we can also write this one. Okay, so this is the one case. Along with that, hydrogen gas you are going to get. Next one, if you are treating with B2H6 with oxygen, okay, 3 moles of oxygen, you are going to get what? B2O3. Okay, B2O3 plus 3 moles of H2O. If you are reacting with oxygen, you are going to get B2O3. Next, B2H6 plus 2Na will give rise what? NaBH4. Okay, Na plus BH4 minus plus NaB2H6. Very, very most important reaction, guys. When diborane, B2H6 is called as what? Diborane. Diborane structures के बारे में पढ़ो. It is having a banana bonds. Very, very most important. It is having banana bonds and 3-centered 2-electron bond. 3-centered 2-electron banana bond is be present between diborane. So these kind of questions we are going to see in the JEE examination, 3-center, 2-electron bond, and they are above the plane, below the plane, banana bonds will be going to take place. Guys, please do remember, this is highly important for your examination. Okay, so dichorin and these reactions are very most important. These 3 reactions are very most important for the preparation of H3BO3 for this one. First of all, see the question, what they are saying. From B to H6 of the following can be prepared except, yeah, we can't prepare this one. Okay, we can also prepare this one, but 45B, we can't prepare this one. No, NaBH4, yeah, NaBH4 we can prepare, right? NaBH4 we can prepare, but we can't prepare this one. C2CH36 means usually any alkyl groups consisting will not be considered. Okay, so consider the following group. Yes, now we are entering into organic chemistry, but I don't want, yeah, time is already up, guys. So thanks for staying back. We'll discuss rest 10 questions in the tomorrow class. Don't need to worry about this one. Then I'll finish the alcohols tomorrow. Okay, thank you guys. Thank you so much for your time. See you in tomorrow class.